Next, we'll learn how to find the limit graphically, which means we can use a graph of a function to determine the limit of that function at a certain point. Let's start with the point from the left. So the question is, if you look at the point where x equals to -10, and the question is, what is the limit of function f of x when x goes to -10? Well, let's observe the behavior of the functions. If you go from the left of -10s, the function approaches to this blue circle. If you go from the right of -10, the function is also approaching to the blue circle. That means the limit when x goes to -10 exists, and the value is going to be the value, the y value of this blue circle, which is approximately 1.1. All right, let's go to the point where x equals to -5. At x equals to -5, you have an open circle, the green open circle, which means the value of the function when x equals to -5 is undefined. Okay, so f of -5 is undefined, so that's why you have this open circle. But the question is not about the value of the function, it's about the limit of the function when x goes to -5. So again, if we look at the graph at x goes to -5 from the left, the function approaches to this circle, the green circle. And as x goes to -5 from the right, the function is also approaches to this open green circle. That means the limit of the function when x goes to -5 exists, and the value is going to be the y value of this green circle, which is approximately 1.3. Okay. All right. Now we look at the point where x equals to 0. X goes to 0. What is the limit of f of x when x goes to 0? So if we look from the left of 0, if x goes to 0, the function approaches to this purple circle, and x goes to 0 from the right, the function approaches to this point, which is about 3.1 as a value, and the y value of this purple circle is about 1.5, let's say, approximately. And you can see that from the left and right, the function approaches to different point, meaning the limit of the functions when x goes to 0 doesn't exist. All right, there's a gap and they approach to different points, so the limit doesn't exist. All right, let's go to a different point. The last point in this functions of this functions is the point where, what is the limit of the function f of x when x goes to 4? And this is 4 right here. And you can see that at x equals to 4, we have a vertical asymptote. Which means if you look at the function when x goes to 4 from the left side, the functions will go up to positive infinity. It will never touch this vertical asymptotes, but the value is just going up to positive infinity from the left side. And from the right side of 4, the functions will go down to negative infinity. Will never touches the vertical asymptotes, and the values just keep going down. And you can see that the directions of the functions at x go to 4 from the left and right are different, meaning they're approaching to different point, meaning the the limit of the functions when x goes to 4 doesn't exist. And as the value, the function goes to positive infinity or negative infinity, later on, you learn that the limit of the functions doesn't exist, and it could be infinite limit. All right, this is how you determine the limit of the functions using the graph of the functions. Again, just observing the behavior of the functions as x goes to the point from the left and x goes to the point from the right. If they're meeting the same at the same value, then the limit exists. If they do not meet at the same value, or they go into different directions, that means the limit at the point doesn't exist.